In this video, we will do parametric analysis of simply supported beam. Its purpose is to determine the reaction forces, bending moment and shear forces developed in it. Application of this analysis is used in bridges, beams in buildings and beds of machines. In this experiment, we will mainly focus on bending when we apply load on it. So let's start. The difference between practical and simulation is that in practical wall apparatus is required, but in simulation we need only free body diagram of beam. Let's create a free body diagram of beam of given dimension. Now our free body diagram is ready. Select the simulation tab on this bar. If not given, then click on SolidWorks add-ins and here select the SolidWorks simulation. After a few moments, it will display on this bar. Select on simulation bar. Click new study. Here give the name of your experiment. Parametric properties depend on the material nature of beam. So select a material for beam to calculate parametric properties of beam. There is a lot of materials and their different alloys. Practically, reaction force of simply supported beam is shown by vertical arrow. Arrow shows that movement is restricted in arrow direction. But in simulation, we will have to restrict the movement of beam in such a way that bottom line of one face is restricted to move in all directions, while other end is restricted along two directions and free to move along third direction. Now we will have to apply reaction forces of beam. The direction of arrow represents the movement of beam is restricted in these directions. To apply force in the middle of beam, the sketch align at the mid is required. After drawing a sketch, go to Features, click on Curves and select the split line. In such experiment, we will to select the upper face on which sketch is drawn. Upper face is splitted into two different faces from middle. Go to simulation. If simulation tree is not showing, don't worry. All the required things are given above. Go to External Advisor, select the force and select the center line. The force is showing parallel to the line. To change direction of selected direction and choose any reference plane. These three translations showing directions along three axes according to the reference plane. It is showing stress, but in this experiment we are only concerned with deformation. So click on deformation. Here the result showing the total deformation which can occur in beam before yielding strength. Show true deformation. Double click on it and select the true scale. Now it is showing true deformation of our applied force 0.5 lb. This is the maximum deflection of this force which can occur at the center of this beam. We can also see the animation of deflection in such a way. To make graph, we just have to change the magnitude of force and have to write it in another Excel sheet. Calculate the deflection experimentally and theoretically. Then make the graph between load and deflection calculated experimentally, by simulation and theoretically. For more such informative and technical videos, subscribe, like and share the channel.